Hey folks, I'm back for another, let's say, hour and a half. Oops. Um, I think we're just gonna see if what we can do about off policy right now, and then we will integrate everything tomorrow, and hopefully we will go from there. We will see. Real quick. Quick round of looking at this. Oh yeah, I see it. Okay, that's good. That's a good result so far. That's like very nice. Very slightly above. Roughly same stability, maybe a little more. I don't know. We're happy with that. We're definitely happy to see that. Okay. Hey, Bet. Welcome. Yeah, the shake just doesn't blend at all, does it? No, it's the stupid blueprint stuff. Go back to this for a second. So offline data really doesn't, off policy data isn't the thing that's screwing us. It's the prioritization of that data somehow. That's really weird. Wait, what the hell? Importance. Isn't this? Wait, this samples with importance. Oh, but importance is advantages, so this is fine. This random sample is the thing that messes with it. Hang on. Yeah, there's like really no difference with the prioritization for this. So you're not expecting it to do better, you just want it to not do worse. It's very weird that it like this is the worst one, right? Maybe the importance ratio is not getting used correctly. I'll have to see. Yeah, so this is the worst curve, you can see it. Yeah, it's following this path. Okay, so maybe there's something in the experience ratio for us for us to think about, right? Oh, this thing doesn't get updated at all, does it? Does this not get updated at all? It does right here. We do like one data epoch though, right? It still should diverge a bit. I mean, advantage takes into account both of these things already. As long as you're using the correct updated ratio, which we are, right? Yeah. I mean, advantage just gets recalced. Ratio is like technically stale, but you can't do anything about that without doing another forward pass, right? I mean, you would think that the really high advantage trajectories would be good. Maybe they stick around too long. Maybe that's it, right? Because, like, isn't top K way worse? Yeah, this is the top K one was way down here, right? So if you keep the same samples around for a long time, they get more and more off policy, maybe. Is there a reason to like keep it anyways? Or is there a reason to keep this anyways versus just like running more epochs? Maybe this corrects so that we can use it more than before. Hang on. It's time for some benchmarking, I think. Did you accidentally paste what you were working on into the stream chat there, Morgan? Okay. This is what we do. Go to none. Here's our benchmark. Alright, enough random code snippets in the chat. Oh, I wasn't using... I know it's Python, but you can use JavaScript to do things. Not in AI, you can't. I'm not running frickin' JavaScript PyTorch models. I like my current stack of Python and C. A lot of C, little Python. Okay, so that's good. So this is our new algorithm. Now what we do, we crank up update epochs to like 4. Say 5 even. So now we see how this does with a bunch of extra updates. This might be too easy to use as a proper benchmark, but we'll see. Okay. So I mean, this is expected. More update epochs makes it train slower, but more sample efficient, yeah. This is like an interesting spike here. Oh, you know what this probably is? This is probably when it wins the first stage of the game, right? Because this is half the score. It's probably really annoying to get that last brick. That's totally what it is. Okay. So here's our graph. It's more sample efficient, obviously. Now the question is going to be what happens when we compare this to the new advantage function? Because this is technically like slightly off policy data now, right? Like it got all this extra data, but it really didn't learn that much faster with PPO, right? Okay. So this is our baseline with PPO. Now we do puffer advantage. It's stuck in exactly the same spot. So like so far it's like a little better maybe. Yeah, but we're not seeing like a massive increase in sample efficiency or anything. Yeah, it looks like this is probably just going to be like a relatively minor but permanent bump, right? Where it's like slightly better. I don't know. I like conceivably it could just do it in half the time, right? I don't know. I mean, so far here we're doing like it's kind of consistent, right? We just do slightly better. I mean, we have. Let me think. Well, I mean, the thing is, like, the fact that this isn't a massive difference tells me, like, I don't think that this is a massive sample efficiency gain. It's like a nice little boost, I think. It'll make all your curves a little bit cleaner. Um, well, I mean, if you want power to find much of a difference, this is the graph, right? This is going to be the neural MMO one. I mean, I was testing something very specific here, right? I was testing the ability of this algorithm to make, to reuse data versus the other one. Actually, you know what? I have a better way of testing it. You're right. Here. We'll do this. In the meantime, I'll look at vtrace a little bit. We should probably graph some of these as well. Or like log this. We'll do that in a second. Yeah, okay, so this was the concern here, right? You go 12 update epochs and it starts doing worse. Slightly worse, which is the same as GAE. So I don't think that this does it for off-policy correction too well. It's a nice little boost. Nice little boost for sure. I wouldn't have screwed up the off-policy sampling ability, right? With we can always try this versus vtrace. Yeah, so this thing sucks. Okay. Now, next we just do we make sure that I didn't mess up something here. Like, it is technically possible. Batch. It is technically possible that vtrace is the sample efficiency one. I doubt it. I highly doubt it. Like 15% that this does it. Maybe less. That's being generous. But we have to test it. I'm going to read a few more off-policy correction things. Welcome, YouTube folks. We've got the new algorithm running. It's like just a little bit better than generalized advantage estimation, which is what we expected. Yeah, vtrace on its own doesn't do anything. It's like just barely a little bit better. It's really weird how bad vtrace is just on its own, isn't it? Oh, well, you do have to tune it to be fair. Hang on, maybe this wasn't fair. Maybe I should have tuned it. Okay, we'll let that run. This is Impala. Well, okay, it's this one. Okay, this thing is ridiculously inefficient. This is like laughably, hilariously stupid. Like the things you'll do for sample efficiency, holy hell. Where's the soft Watkins thing? Okay, here's soft Watkins. Agent 57 uses retrace to compute return estimates from off-policy data. It tends to cut traces too aggressively when using epsilon greedy policies, thus slowing down propagation of information. Alternative return estimator, which we derive from Q of lambda, Watkins, whatever. We propose to use a softer trace cutting mechanism by adding a fixed tolerance parameter and taking the expectation of trace coefficients under pi. So what is this? Well, this is like vtrace right here, right? Fixed tolerance parameter. What the hell is this soft Watkins thing? They have an ablation on this? Surely they do ablations, right? Soft Watkins. I don't understand what this is. What is this operator? So they take... Is this 1? The heck is this? Oh, indicator, yeah, 1. Okay, so what they are doing here is this is like, so this lambda I is the importance ratio, clamped importance ratio in our thing. And here, they define a change in Q. So I think if the Q function changes too much, they just drop them, I guess. So instead of it being a ratio, it's like a hard clip. So it's actually kind of more similar to this for what we would do because we don't have the Q. Oh, so they do it whenever the action changes, I guess. Oh, so whenever oh, okay, I see. So whenever the optimal action changes or whatever. That's kind of cool. Stuff like this we can potentially do, yeah. The thing is, our policies are stochastic, so like, it doesn't quite work the same. Also, this experiment failed horribly. So, not as badly as before, but like, yeah, vtrace alone is not amazing. Okay, so now we know why our off-policy stuff isn't doing great. It's because these things just aren't great with off-policy data. Yeah, so their stuff is like, this thing is, where is it? Yeah, so this thing is very much dependent on having a queue function, because they prevent data from going off policy. The trust region maps out the loss at any time step which both of the following conditions hold. So this is the clip. Sign of the difference. Well, what's the G is the return estimate? Isn't there a caution param in Muon that's like kind of similar to this? What else did they do? Okay, so they do have a policy distillation component. Yeah, so this totally breaks it, right? This caution thing totally breaks it. We don't want that, right? We'll double check. Are there any other of these flags? caution. Yeah, okay, so this recovers like original perf here, right? What? This one didn't seem to be that great. I didn't think this Mars thing did anything either, right? Let's fiddle with a few things now. Yep, not great. Oh, you dummy. You've been putting them on the wrong one. Alright, let's try this correctly. Stop looking at noise. I must have applied caution correctly, right? Because that was like a big delta. So yeah, that's not great. Let me make sure we're recovering original perf here. So something like making me uncomfortable with this. Make sure we recover perf. So how's this? It's good. Okay, we're not recovering original perf. Oh wait, we are recovering original perf. These were the high sample ones. Okay. You know, we're good. We're good, because these were the, yeah, these were the, yeah, we're perfectly good here. Yeah, I gotta be careful at this hour. I start making dumb mistakes. I think I did apply caution correctly here to this though, right? We'll try that. It's 827. Let me look at PPG again. And that's like a huge difference, right? Where's the algorithm pseudocode? I'm trying to think if we can like hack this. I think we can hack this a little bit. So what I'm thinking here, right, is we optimize the policy and the value function jointly for an epoch, and then we can optionally add additional value function epochs. And the value function. L joint L value. Okay, I think we try it. What happened with this one? Yeah, okay, well, I got it right the first time. This is way worse. Let me go grab those other previous graphs as well. Okay, so these were like yeah, we've got our baselines. This was like the data reuse. How do we do this? KL. We have this up here. Scale gonna be with this. I'm being lazy, but I think it's just like one ratio over the other. Literally just subtract log probs. We don't want to pull it to the we don't want to pull it back to the original policy though. Yo, Spencer, how's it going? We made some really solid algorithm progress today. We came up with a small but seemingly very stable general purpose improvement to advantage estimation. So that's solid. This is stupid. And go look at the policy. Oh, I see how this works. Yeah, that's really obnoxious. Should be able to start doing full-time RL going forward. Awesome. Yeah, let's catch up over the weekend. I might have some cool stuff for you. Let me actually go send one message right now. This portion makes it infeasible right here. Oh, I know what I can do though. I know what I can do. I know what I must do. Uh, Still not amazing. Let me just try to get something going real quick, right? Something real quick like. Do this shit. Come on. What we're gonna try to do here, the thing is it's a little bit of a hack. Do I want to do this, man? I think I'm gonna end up unlearning the freaking policy. How the hell do you do this? There's like no good way to add a cloning objective at all. Maybe this was right. We just do. Maybe we would do this. First, we make sure that it doesn't change anything. How's your Vim scroll so smooth? This? What do you mean, this? Like, this is just default NeoVim, my guy. With, the one trick is you always increase your key repeat speed on your OS. It's like one of the first things I notice is default key repeat. Default key repeat speed is like awful. Okay, so I somehow broke something. I guess. This doesn't work. Right? Vim cursor looks geriatric. I have a total of 2 plugins in this. I've got Semshi because Python syntax highlighting sucks, and then I've got Super Maven for like, I don't know, typing speed boost. So what happened to the epoch here? Okay. Is this thing matching? So this should match because it should never hit this cloning loss here. Okay, perfect match. And now it'll hit the cloning loss. And we'll see if that does anything. Oh, good. How would you like to see a reproduction of scaling laws paper? Which one? So the one I know that's like, there's single agent RL scaling laws. This one's pretty good. This is, where's the Schulman one? Yeah, this is the Schulman one. And then there's the scaling laws for board games. This guy is smart, but completely insane. This was a pretty cool paper. So it depends which one you mean. He founded one of the biggest RL discords back when it was active. Was one of the first people to go to Anthropic. Told me they were like terrified of all of my neural MMO things because, oh no, it's like dangerous AI, and that they were going to be like the role model for how to do safe AI research. And now they're doing completely closed source AI resource and are, defense contractors as well, which I'm generally fine with, but not exactly at all what they said. So I don't know. I generally think that especially early Anthropic folks are just completely batshit. Google has a 10% stake. I forgot about that. Is that even a thing? Oh no. But yeah, I generally like the early Anthropic people who are batshit. Some of them now are probably just like, yeah, it's a big AI lab like the rest of them. But the early original split was complete batshit. Very good paper though. One of my favorite papers actually. It's like one of the best done RL papers I've seen. What's this? Is this way faster? Huh. Interesting. Early Anthropic are all, yeah, like I said, batshit. Like I said, batshit crazy. TD. That's immediately better, right? Not much. Is better though. Yeah, there's not really like a cute hack way to do this. So what I was trying to do is I was trying to find like a hack way to do something approximately PPG, phasic policy gradients, but without the fixed cost overhead. It doesn't seem like there is a good way to do that. There's not really a way we can get additional value function training in, right? We could. Okay, one last thing I'm going to try really quick. One last thing I just want to try really quick. So this is like really low clipping coefficient, and then extra epochs. Does this do anything? Doesn't seem like this does anything. Yeah, not great. Value function coefficient's already quite big. Okay, so none of these tacks like really do anything. You'd have to do full phasic policy gradient, and I don't really like that because you have to go through the whole data set again just for the privilege of then being able to do even more work. I mean, I guess it's, hang on. Okay, actually, maybe it's not bad, come to think of it, because times it 907. Okay, you know, maybe it's actually not that bad. And the reason I'm thinking that is you only have to do the extra forward pass if you get through the whole data set, right? Or if you get through your, if you're going to do multiple epochs. So it should be purely a method of scaling up. Okay, we'll mess with this tomorrow. I think that there is actually a world in which this works. So I'll explain the idea briefly. So here's the thing with phasic policy gradients, right? This is the algorithm. This is normally what you would do with PPO. Okay, so this is now, you have to double your compute. And then you have to redo the whole forward pass, so that's like another 0.5. And then you do a bunch of extra epochs on both of these. So what I'm going to do instead is it's just going to be, we do one epoch of this all together, which is the exact same cost as what you would do for PPO. And then if you want to do more epochs, then you do this once and then you do this stuff. And then ideally what that means is that you maintain exact equivalence with PPO, but then you essentially just strictly add an option to train the value function more. And we'll see if that does something. Hypothesis here is that it should do something. Hey, Ryan. Yo, Ryan, does this make sense? Why does that not work? You just jointly do one PPO epoch, policy loss and value loss. Yeah, but who cares, right? But like, who cares, right? No. What I'm saying here is you literally do the first epoch of PPO stays PPO, or the first n epochs of PPO stay PPO, right? And then you have the option to add epochs that just train the value function. and keep the PPO output exactly the same via the KL divergence. So essentially what I'm trying to do here, right, is they show here that like you actually make the policy do worse after a while, and I can reproduce that result as well. If you just keep putting more data through it, you do worse because data gets increasingly off policy. But you do better if you train the value function for longer, right? So what if I just make this split, right, where you can do extra epochs? Sort of defeat. How does it defeat the purpose? It lets you do PPO and then do extra value training, right? If you just want, you do need the aux step. You do need the aux step. You can't tune up value epochs independently because you're assuming it's a shared head. And if you have a shared value head, then you crash the policy if you don't have a behavioral cloning loss. But you can't have a behavioral cloning loss while you're also training the policy. Right? So what I'm saying here is you just have this. You don't have a separate value network. You use the shared mode that they said works, right? Here you train. This phase is just PPO. You do PPO for an epoch or two. And then you do this. And then this gives you the pi. This essentially gives you your new updated logics for everything. And then your new updates go over that. Yeah, it is a behavioral cloning loss bet. I think this might work. I think this should work, really. Value function doesn't interfere. Well, in that case, they're doing, they have like this other version of it though, don't they? Hang on, where's this other version of it? Eh. They don't have the ablation on why this matters though. I guess they also say not to do the aux phase too often, right? Isn't that a thing? Like, don't do the auxiliary phase too often? Yeah, okay, that actually might be kind of sketchy. Like, why does it interfere though? It doesn't. It just says we think they interfere, as far as I know. Well, the goal is to decouple value function training. The thing is, the other thing this lets you do, right, is this lets you train the value function more than the policy. Right? The main result, as I read it here, is that if you train the policy more than an epoch, it does worse. Why can't you just do that with PPO? You can't just train the value head. If you just train the value head, you corrupt the features if you're not also training the PPO loss. You need to have a behavioral cloning. Like, if you're not going to train the policy head, like to improve the policy, then you have to behavioral clone it against where you started at before you started training this value function even more. So the goal is to keep the policy doing the exact same thing while you keep training the value function more, right? So the policy develops for one epoch, and then you can train the policy, the value head of the policy a whole bunch without destroying the policy logics. You can't just train them separately. I was suggesting, right, our default implementation basically always does one epoch of PPO, right? So I'm saying do one epoch of PPO, and then if you want to do more epochs, so if you want to like crank up compute, then what you can do is you can go compute updated logics through the data set with the thing that you just trained for an epoch, then behavioral clone versus that so that the policy doesn't change, and keep training the value head. Okay, this is also kind of sketchy here, right? They say that the baseline PPO does shite if you use separate networks. And this gets to 0.6. And what are they claiming this gets? 70. Force an awk step if you increase value epochs. Well, yeah, the plan is you do n PPO steps. Optimal's probably 1, but it's like prioritized sampling, so who knows. And then separately, right, you can do value function training followed by, or simultaneous even, value function training and behavioral cloning. Let me get rid of that bot. I think it makes sense. Here, let me just real quick. Oh man, did you just link me Gale? Is this remotely similar? No, not like this. Expert trajectories. There's no. Is Gale offline or something? There's no expert data. Yeah, there's no demonstrations. How the fuck is there an imitation library? A whole library for that shit. It's easy. Supposed to be taking a break. Theorycraft PPG stuff tomorrow. Cool. Fraction PPG we could potentially look at. Why did you say it wasn't great originally? Did it not reproduce the paper? Use CleanRL's version. It was just slow, I guess, right? I would imagine it to be slow. Combine with PLR, which uses value predictions. Huh. Weird. So the way I was going to implement it, right? Base PPO is exactly the same, zero change whatsoever. It purely gives you additional value function training. Wait, they only run it every 25 PPO updates? So that's going to mess some stuff up. Let me see, there was an aux frequency ablation. This might not be worth doing then if it's... Because you have to do it jointly for it to be worth it. Like, you'd have to do it jointly. Okay, so this isn't worth it then, right? Look, this goes back to 0.6. It shouldn't require that, but I think the whole thing breaks here because, yeah, that basically brings it back down to PPO perf. So doing yeah, if you do it too frequently, it harms perf. So I was gonna do it jointly. So that's just not gonna work, right? Did they benchmark this versus just doubling the network size? They probably didn't, right? You know, I'm kind of starting to wonder here, Ryan, like, they use two separate networks, but they say it still works with this. Or is it? It still works with single net. Well, it actually doesn't make any damn sense that this works, right? Because, like, think about it, okay? So, like, they just have the value function head. The point is that, like, the value function learns useful features that you then distill into the main network, right? But there's nothing to distill because the value head function's just like a small head. So there's nothing to distill. and somehow they're still getting perf. Well, I guess that would mean if there's nothing to distill, I guess it's the fact then that they are doing additional full gradient value training, right? So actually, no, this still does make sense. Shit. I think this will be worth playing with a little bit tomorrow. If I weren't exhausted now, I could probably just do it in an hour. I think I'll just do it in the morning. We'll see. If it's not promising, I won't stick with it very long. But this was basically like one of the methods I wanted to play with for increased sample efficiency. Yeah, I have looked at it a little bit. I mean, if you read it this way, right, this is like 2 to 3x sample efficiency that they are claiming here, right? This is like doubled sample efficiency. More than doubled, like 3x. Actually, Ryan, here's another thing, right? So look at this. If you do detach the value head, right? If you detach the value head here, then, wait, what's this B? Oh, that's just entropy. So if you attach the value head here, then you can do this at the same time, right? Because this doesn't interfere with this. So you can do this at the same time. So this is just PPO with detached value head. And then every so often you run this. So you just do this as the joint first step, first epoch. And then you run additional of these. And then every so often you do this. Do them together unless... Well, yeah, but the thing is you can always do... Let's say you're going to usually do one epoch of PPO. You also get one epoch of value function training basically for free. Because you batch it, right? And then this is like a pure extension, right? It's just like a pure extension of this. You know, one thing I want to try just real quick before I... What if we just do... And make sure that this is our baseline, and then... What if you just detach the value head? What happens? Ignore the stop grid, it still works, yeah. It's very close without it, though. Like, let's see what happens if I do... I think that's the same initial curve, right? Yeah, this is fine. This is the same initial curve. What happens if I just do this? Like, just literally detach the value head there. This is baseline, by the way. These are like more epochs. It does better. Look at that. It literally does fucking better if you detach the value head. I think that's like enough of a cue that it's worth looking into, right? Oh, you know one other thing we can do real quick that would make it really, that would be really easy? Hang on, we're gonna try something really, really quick. So this is true or, so this is just PPO, right? I'll do like this. Yeah, let me do this. Well, apparently something wrong because this shouldn't have failed. Hang on. Hang on. What did I screw up? It's a 0. I wanted to see with detached value head if you can now just train it more. You should definitely be able to just train it more. Something's wrong. Yeah, so that runs. No, I want to just, it's just going to train the value head more. If I zero this loss, it doesn't do anything, right? Yeah, this can't do anything. Running rate tracking. That could be a thing. It's muon, probably maybe similar. Oh, that's annoying. I mean, that doesn't explain it failing this hard, though. I don't think it does. Oh, you're a dummy is why. I detached the wrong fucking state. Yeah, that'll do it. I don't know. Let's see if this is could have been noise. Let's see if this actually is like significantly better. That's still the wrong one. What the fuck is wrong with me? Okay, this has to work, right? Yeah, I know. Last experiment. Fuck's sake, man. This is the one that we're calling, right? Well, maybe this one just doesn't work at all. Ah, yeah, here's the issue. If you detach the value head, the network just trains like shit. Whereas the logit actually works. That's kind of crazy. Wait, is that actually true? That's kind of crazy, right? Like, look. You detach this here. Can you just detach? Can you detach this one? And have it still work? Yeah, dude, you can detach. You can detach the policy head, but not the value head. Isn't that kind of crazy? Though interestingly, I think I detached both and that was the best of all of them. Let me see for sure. What's training? Good question. Maybe that was a bug. We'll see. That'd be pretty funny, wouldn't it? All right, so you can detach one or the other. And then if we detach both. Oh, you know why? It was because this doesn't get called anyways. This is called during eval time, so that's why it worked. And then the improvement was just noise. Okay. Yeah, this is not like this will fail, I'm sure. This will fail. But still, that's interesting, right? That you can detach the value head, but not the... Yeah, and then you get a failure because there's no gradient. Yeah. Yes. But I mean, that wouldn't really lend itself to any major conclusion, right? That just tells you that you need to learn the both. Which is like, yeah, duh, you need to learn them both. I mean, like... Do any of these things have as much effect as just doing this? You gotta admit, it's pretty cool how fast we can run these, right? These are 80 mil experiments. You'd be waiting an hour a piece for these normally. You'd think it would impact PPG though, right? There's something there. There's something here. Start testing dumb ideas on Puffer Breakout. Well, the thing is, it's not just Puffer Breakout. You can do it with Pong, and that'll run in 20 seconds. And you can do it in Snake, and that'll run in a minute. Yeah, I'm trying to figure out what the hell it is the thing that they're on, like they're up to is with that. Here, let's see what happens just by making the network a little bigger. Just like magnitude of effect kind of a thing. Okay, so this was like 4 epochs. Yeah, it's worse. Lol. Thanks, RL. Okay, actually, I understand why it is that that happens now, though. That's going to be gone pretty soon. That will do better in the future. Was better for a little bit. Is there anything to phasic in that case? It's weird because, like, the PPG, they say the PPO baseline with separate models does shit. But then, like, isn't there that annoying Google, like, large scale? What's it? What matters? This thing? Didn't these guys find that shared was way worse for their shit? Figure 15. Do you think this is stupid capacity issue? This stupid shared network thing, like versus separate's always bothered me. What the hell's this baseline cost? I don't know. The authors of this paper fucked my stuff at Google. Do you think their paper shit? That'd be fun. Because they come up with a lot of things that don't really hold across the whole rest of RL since. Care why I couldn't publish for a year. Dipshits. Yeah, the funny thing about this is these 4,000 choice configurations on like puffer tasks, this would be like, you know, a box. Okay, well, I think I should go to bed actually, to be fair. And I just want to do RL fucking 24/7 now until it's solved. It's like I got the RL bug. It's gotta be solved. Hmm. PPO implementation used for Google's RLHF was based on the implementation from that paper, and it had a bug that made it really bad for a year. Oh. They are shit, huh? Alright. They get really weird results that don't really match anything in the rest of RL, right? It is also shitty control stuff, though. No one used PPO because of that. They didn't because of one shitty... Oh, man. What do you say we... Like, who's gonna win, right? The fucking multi-trillion-dollar company... Or me with one pufferfish? Alright. Apparently we have 11 people watching at this hour. So here's the deal, folks. I gotta get sleep, but I will be back first thing in the morning. All my stuff's open source here at puffer.ai. We made a pretty nice breakthrough today with the new advantage algorithm. If you want to help us out for free, literally for free, takes 2 seconds. Just start the repo. We're almost at 2,000. It'll be great. Other than that, you can join the Discord to get involved with development. You do not need an RL background to get involved. Some of our best contributors, actually all of our best contributors now, had 0 RL background coming in. Programming background helps, but a lot of this stuff's actually pretty nice and easy to pick up. But there's a lot of like cool self-contained dev you can do. It's a lot like low-level game dev, except you train superhuman AIs on it. So join there if you want to get involved with that. There's also a blog post on how to get started. And you can follow me on X for more RL content. But yeah, that's the vibe around here. We do research live, some engineering, some science, some math. And yeah, back first thing in the morning. I just get a message from someone like, hi, whatever. Hi, yes, it's me. Oh, that was separate. Okay, cool. Well, yeah. See you, folks. Thanks for tuning in. Bye-bye.